I'm hoping just that everyone is hearing very well. In the back, in the front, everyone is with me. Everyone's sleepy. Because I have to be honest that I cannot believe that I arrived in Brasov on Monday, and I had to work, which I never do in Brasov. Like, Brasov for me goes in the concept of vacation, relax, hiking, all sorts of stuff, not working. So yeah, it's like a work lag kind of thing. But anyways, it's very nice to be here today. I just was on and off to the conference, so I saw that the vibe is very nice. A lot of great people. Everyone is happy to have Code Camp in Brasov. Do you want more? I don't hear it. So, a little bit about myself. I like to think about me as an engineer, but an artist at heart. So my way of doing this is while, preparing presentations or content, or, from my experience, for the things that I learned along the way. And I hope that today you had, until this moment, and I'm sure it's going to be also further like this, a lot of interesting insights, technical stuff. We are going to discuss today more about how we think about working with this technical stuff that you are learning today. So coming back to me, although I don't like to do this, but whatever, you have to do what you have to do. I'm an engineer right now, not doing that much of coding, but still I can let go of this field yet, so no people management on my side. And when it comes to these events, this kind of events, always I'm saying yes if I have something interesting to say. How many of you know this building? Have you visited? Yeah. So this is the Cathedral of Santa Maria del Fiore, which is in Florence. It's an amazing, amazing building, amazing architecture. So I just want us to do an exercise right now and imagine that we are standing right in front of this cathedral, marveling at its amazing design, thinking about how the architect who built this cathedral had to think about how this building is going to withstand the test of time, how it had to look at every detail and think of all the components and elements that had to create this structure in order to withstand storms and to receive a lot of occupants and tourists lately for over decades and decades to go, and who knows in the future too. And I want now to shift that perspective to software development, because, as developers, we often focus on the task at hand. We are either fixing a bug, deploying some feature, or just, thinking to the next thing that we have to do. But what if we approach our work the way that architect did? What if we think a bit more on, instead of solving today's problems, thinking in perspective? And also think about how we are approaching decisions, the problems that we encounter, the challenges that we have to work with. So just as an architect considers the life cycle of their building, so should we look at our software like this. If I think twice, I dare to say that I want you to remember this analogy. You are not just building, writing code. You are building a digital skyscraper. Sounds good? Anyone feeling that is doing this at this moment? Working on something meaningful? I'm just going to suppose that this is because of the fact that you had lunch and not because you hate your job. Anyway, as programmers, we find it challenging, right, to just look at our code the way we are looking at a building. Most of the times we are deeply engrossed in the tasks that we have to do every day. So this also shows us that we don't have the same limitations. We don't have the same perspective as we have in, construction domain. Let's just think for a second. Building a house with 1,000 doors, it's impractical, right? It's not cool, unless you want to have a way out from any discussion that we have with your partner. Maybe it's a good idea, but thinking about the architecture and the system as a whole, it's not a practical idea. But if we switch it to software, we can do anything. Anything is possible, right? Even the impractical decisions seem good. We can actually paint the walls before having the walls. That's how much flexibility and freedom we have. But despite this freedom and flexibility, when it comes to our ways of thinking, we are very specific and hardly ever accept a different opinion or a different way of looking at things. Even when we do, we still tend to stick to our outdated beliefs and to the things that we already know, the patterns we already tried, the structures that we already worked with. So mostly it's about the way we already build our way of looking at things. But if we reflect, we are going to see that this is a great tool for learning. Basically, in the moment when we feel that we are unlinked from the things that we are building, and we feel that, okay, I made a decision, I'm not really sure about if that's the decision, but I don't really care, that's the moment where we need to stop a bit and see exactly why are we doing this. By breaking this cycle of making decisions, going further, not assuming our mistakes, not learning from our mistakes, by breaking this cycle, we can actually adopt a growth mindset and focus on the things that are going to create a more pleasant work experience, but also help us make better decisions. And in this moment when I'm telling you about mindset, I'm referring to the attitudes and beliefs that we have and the lens through which we look at our work, at our tasks, and all the things that we are doing in a day while working on the projects that we are having. How many of you ever thought about, okay, I'm having a growth mindset or I'm having a fixed mindset right now? How many of you know about growth mindset and fixed mindset concept? Okay, we have some hands, that's good. Let's take it one by one. If you, at some point, looked at a task and you've been like, yeah, I don't really understand how this is going to work. I'm never going to learn this framework. I don't know how to work with this. I'm just not good for this. You are tapping into a fixed mindset because you are considering that your intelligence and your abilities are fixed. Whatever you do, you cannot change them. And this actually, as developers, make us more shy to challenges because we don't take opportunities as we would do if we would have a growth mindset. Thinking that, okay, by learning and through adaptation and through collaboration with others, we can build knowledge and actually have an impact. So we shy away from the chance to grow. No, we are not discussing about, I really hope, but I can promise. I hope that by the end of this presentation, I can be proud of not saying anything about AI. I'm not sure I'm going to be able to do that, but let's see. Anyways, there is this book, and I really like the comparison that it does in this book, related to how we have in aviation industry a growth mindset, and in the medical field, we have a fixed mindset. While in aviation industry, we are using the black box, the flight data recorder, to see exactly what went wrong, analyze data, and try to do better in the future. In the medical field, it's not like this. It's more of a fear of losing reputation and being exposed to legal consequences. Hence, why we have more developments on the aviation industries, and in the medical industry, we are still trying. So now that I hope that everyone has it very clear what is the mindset, the growth mindset, the fixed mindset, and that we are all aligned, I want you to, I'm not going to ask any other question, but more like challenge you to think for a bit and see exactly where you are. Are you limiting yourself with the way you're looking at the work that you're doing? Are you actually being a person that is open and accepts feedback? Do you accept feedback? Actually, yeah. Actually, I realized that this is the #1 indicator if someone has a growth mindset or not. Do you accept feedback? Not so much. We don't like feedback today. Okay. Nonetheless, we are going to discuss about growth mindset further. And I like to say, to tell stories, so I'm going to start with a story. I heard it, I think, in a student organization years ago. So I don't remember exactly who is the author of this and all the details, so copyrights to anyone who first said this. But one day a man was going, towards a hill, and he saw many people breaking stones. So he got curious and was like, what are these guys doing? Let's see. And he asked the first person, and the first person was focused and kind of, bothered by the fact that it was disturbed because he was doing his job. And his answer was, I'm breaking stones. Our man, it was a bit confused, so he went next and next and next until he found a person that was very excited about what was doing in there. And he answered, I'm building a castle. So as developers, I think we all been through situations when we've been building castles and other situations where we were just breaking stones. We are mostly going between being very effective and documenting things and being very excited about our work and doing code reviews and setting meetings to discuss about the implication of the work that we are doing. Other times we are just like, don't bother me. I have something to do. I just want to look at my task, want to deliver, and that's that. So both of them are good approaches, but it seems that we are disconnected from the work that we are having. And it's not about complying with one way or another. From my perspective, this happens because we are not very honest and open to the things that we want to do further in our career. Maybe it's because of the fact that is the context the way it is in IT. Maybe it's because we are working on projects that we don't like, as we've seen a bit before. In any case, we need to stop waiting for the things to happen from outside and to create some impact on ourselves. This is the circle of competence, and this is a tool for growth and for actually understanding where we stand and why are we so uninterested maybe sometimes in our work, or why aren't we finding the balance that we need. So the first circle that we have is about the things that we know. So basically, we can ask ourselves, okay, what are the things that I really like, that I have a deep understanding about, that I know I can confidently work? This is our inner circle, is the things that we know. And this is the knowledge that we need to use when it comes to the projects that we are working on at this moment, without overextending to the areas we are not sure that we can actually give opinions on work on. Then, as we go a bit further, we might find in our projects subjects that interest us, that are interesting to us, but we are not sure that we can approach them. This is extending our inner circle, right? Going to the things that we know that we don't know. So we start doing maybe some peer programming, taking some easy tasks, step by step gaining some competence in that area. And I would like to highlight 2 risks, let's say, in this part. On one side, have you ever had someone, while you were working and trying to meet that deadline, come to you and ask, why is this taking so long? If I would do it, I would finish it in 2 days. Why is it taking 2 weeks now for this to happen? Have you had? We are not saying from what role, but, have you had? Yes, you had. Well, don't be that person. That's my advice for today. I'm going to go now. No. Don't be that person. There is actually a concept that is called Dunning-Kruger effect, where actually it's being studied by psychologists that the fact that people that have less competence in a field have the tendency to underestimate the work that they have to do in that field, and people that actually have competence and can have very good insights, they are underestimating their capabilities to do that task. So that's why it's important for us to be honest about our circle and where we are, and if we can actually work or have opinions about any area. Another risk that we have, I think it's affecting our mindset more than we can imagine. It's the way we think about the work that we are doing. How many .NET developers do we have in the room? How many Java developers do we have in the room? How many JavaScript? Okay. When we are thinking about ourselves, for example, that I am a .NET developer, suddenly you become kind of stuck. And the same goes for Java, JavaScript, whatever. If I'm thinking I'm an X developer, I'm stuck. If I'm thinking about myself that I'm a developer that is working with .NET or Java or JavaScript, wherever, then I become a developer that can know other things too. We don't realize the fact that when we are saying about ourselves, I'm a .NET developer or Java developer, I don't discriminate. Basically, we are limiting ourselves to that technology. Our focus, it's like reinforcing the bias that we have. Our focus, our learning, our passion goes into that direction. And we don't realize that we are not actually working in becoming better at the work that we're having and evolving. And suddenly, we wake up one day that we are sick and tired of this .NET Java environment, and we don't know what to do, so we are switching to painting or something like this. Whatever people do these days to get out of this technical environment. And if you've seen, we discussed about the inner circle, the circle of the things that we know, that we don't know, so we are developing in that area. But we did not discuss about the third one, which is the things that we don't know. And those are our blind spots, right? Because we cannot be aware of the things that we don't know that we have to be aware of, and we cannot look for the things that we don't know are there. And this is the moment where I'm doing a book recommendation. Actually, it's several books. They are called mental models. Of course, this is the general one. There are in different fields, biology, physics, and so on. And some of the discussion that we are going to, part of the discussion that we are having today, you are going to find it even more and better explained in these books, not related to IT, but in general. But what I want to point out in this, at this point is exactly this part of the things that keep us in this loop of creating blind spots for ourselves and actually not being able to move over. So first is perspective. It's about the mental frameworks that we have, the way we look at things, the patterns that we learned, maybe from someone that's been our mentor at some time, maybe from the team that we've developed some skills. I can say for myself that I had a very long period where I found it very hard to adapt in new companies because I was so stuck in the model that my first company gave to me. So it was very hard for me to adjust and to actually be open to more ideas. So this is perspective, and we are going to continue the discussion on the perspective. Then we are discussing about ego-induced denial. And we were discussing in the beginning, right, about the fact that we don't really accept new ideas. We don't really want the others to know that we are limited in some way, and that maybe we don't know as much as it seems. We don't usually ask for help that much. We try, like 3 days before actually asking someone to help us with that task that's been bothering us. And the third part is the distance from the consequences of our decisions. Especially in big organizations, this happens when we are making decisions, even in our code, or in the teams that we are having. But we don't know exactly the effects of this, because there are so many layers of management that they don't really get to us. So we keep doing over and over and over the same things, using the same mental patterns. And this becomes, like a broken window effect. If you know the concept, when a space that is not taken care of invites even more damage. So this is what is happening also with our processes and with our way of doing decisions, and we gain confidence that our decisions are very good because we don't see the consequences of this. And going a bit further on the perspective part, when we rely on just one way of thinking, we limit our perspective. Great thinking comes from having insights from different fields. For example, in school, we've been learning about physics, we've been learning about history, we've been learning about mathematics, economics, a lot of fields. But in real world, we cannot apply them as neatly as we have it in school, right? We need to understand several concepts and being able to actually combine them. So if we only focus on one of these, it's going to create, again, those blind spots that we were mentioning before. So without a multidisciplinary thinking, we miss the full picture. For example, we have this concept of a Swiss Army knife, which it was most popular way of thinking of Charlie Munger. So basically, he was saying that you need to have in your cognitive toolkit a lot of tools, mental models and patterns, just the way you have in a Swiss Army knife, a lot of tools that you can use depending on the problem that you need to solve. And talking about the limiting perspective and not having enough tools, it's also that saying that to the person with only a hammer, everything looks like a nail. Yes, but not everything in this world is a nail. Just go into a forest with a biologist, a yoga trainer, and real estate agent. Their perspectives are going to be completely different, right? One is going to be amazed by nature. The other one is going to think about the business possibilities that are in there. The yoga trainer is going to think about how you can meditate and find your inner wild person. And each of these perspectives are correct. None of them are wrong. It's just that they are missing the whole picture. And add to this the confirmation bias, where we are looking always for evidence that validate the things that we think about ourselves, about the work that we are doing, about the environment where we are. And let's take a more specific example. How many of you have read the Yellow Book? A pattern language by Christopher Alexander. We have in there in the back, and also in here. Great. How many of you know this book? Cool. Developers conference. So it's easy to see what is the focus, but you'll be maybe amazed to find out that they have a lot in common. But let's start with the yellow one, because it seems that it's not that popular in the room. Christopher Alexander was a pioneering architect, and he actually introduced the concept of patterns, which are reusable solutions for recurring problems, right? He did this in architecture, but it seems that these patterns were very good translated in the software development field through the design patterns that we are using in our day-to-day work, and we are discussing in conferences, and that help us build systems that are modular and scalable and maintainable. Alexander's work demonstrates precisely why drawing from different fields helps us have a better view on how we can solve problems. For example, urban planning provides us some models of scaling systems. Biology helps us with expanding interconnected networks. Right? We're thinking about how things are connected, right? Our components in our software, for example. Then we have psychology, which helps us with user interaction, yeah, creating user-friendly in our applications. So Alexander's work shows that drawing from these fields can help us have a perspective cleaner, and actually, he created something that we, in the software development, have embraced in the 1990s when these guys, as they are called the Gang of Four, took the idea of patterns from Alexander's book and translated it to software development, which are it's now a book that it's extremely popular and that it's helping a lot of projects build code in a structured manner using some rules and so on and so forth. So the most innovative ideas come from having an open mind to other fields too. Then we go to the second mental model, which is map is not a territory. How many of you, when you need some clarification or you need to understand the context of your project, are going and checking a diagram that you have for the architecture, for the way your data flows, for the interactions between components? Are you using diagrams? Can architects in the room tell us what kind of diagrams? So you are looking at structures, right, in one way or another. But do you think those structures actually give us all the details that we need? Are they a true reflection on what the system is actually in reality? Is this map a true reflection of reality? If I zoom in a bit more, is this a true reflection of reality? It's telling me, for example, about how large are the streets, or how many kids are playing, or how many cars are being on the street. Is it? It's just a representation. For example, I cannot know about some pothole that appears somewhere in this area. You have to resolve this, Parashov. So basically, if we translate this to software, we can think about, okay, I have this amazing diagram from for the architecture, right, a high-level diagram. And I can see in there some data flows, some interactions between components, but that's it. When we are looking on what is happening in the real world, in the terrain, we are going to see that there are a lot of challenges, that we have a lot of unforeseen failures, maybe situations that we cannot in any way see in our diagrams that we like so much. Third mental model for today, it's the second order thinking. And as I was saying, I like to tell stories, so here's another one. You like it or not? I hope you're not falling asleep because of the stories. I think you're not, but let's see. So basically, do you know the concept of Cobra effect? The story goes that when a British colonial government occupied or were in Delhi, they wanted to get rid of the cobras on the streets. So they created a program where people that were catching and killing the cobras are receiving a reward. But there were some entrepreneurs of the time that thought, what if we breed cobras, we kill them, and then we go and, take the reward and that's it. It seemed like a good idea until the government found out about it, and they thought, okay, we are going to stop this. And what was the consequence of this? The cobra population increased even more, and there was a bigger problem than it was in the beginning. And this shows us lack of second-order thinking. So when we are discussing about this mental model, we are discussing of seeing beyond the immediate consequences of our decisions, to actually look at long-term effects and even ripple effects, if you'd like, in order to understand how those decisions are going to impact us in the future. Let's take scenarios. We like e-commerce platforms, so let's go with that. So let's say that I have to build an e-commerce platform, and I'm thinking, okay, I have to deliver the basic features, right? I have some specifications, a shopping cart, user management, listings, payments. So basically, this is where I'm first thinking, right? Maybe I'm thinking also about, okay, let's improve a bit performance in order to give a good experience to our users. But if we leave it just like this, we might find a lot of unforeseen situations, right? Because consequences of our decisions, like not taking care of performance and the bigger load of users, not making sure that the way we are handling payment it's a secure matter, and you name it, any other question that we can ask ourselves in when analyzing and developing a new application. If we are not doing this, we might get stuck and lose sight of scalability that is needed, availability and fault tolerance, performance, security, and so on. So by asking some questions more than just the obvious, we can actually see a bit beyond the things that we are building right now with the information that we are having at this moment. And we can go even further, like go to all sorts of fancy stuff that companies are doing and using nowadays. I used AI. Anyways, yeah. Yeah, but it's biology. I did not say AI. Anyways, this approach helps us see unintended consequences, plan for future needs, and actually avoid, quick fixes that are going to bring some issues in the long term. Relativity. You know that story with the two fishes that were just swimming, and another older fisher comes, and he's asking, how's the water? And the other two are being very surprised and asking, what the hell is water? Sometimes, especially when we are choosing technologies for our applications, we are like those two fishes, not thinking about the context that we are in. I remember some years ago, I was, and this is my favorite issue, let's say, in software development. Some years ago, I was more focused on the front-end area, and there was this debate between Angular and React, and everyone was fighting which one is better. Which one is better for what? For learning? For solving problems? But what if we change a bit the perspective and understand that things are not absolute, and that we need perspective and we need context in order to make a better decision? And instead of asking what is the best language or what is the best technology, we ask what is the best technology for my project? What is the best technology for your project? So there is no comparison between the two without actual context, because context is being summed up by timelines, project requirements, team skills. These are things that we need to take into consideration. And a lot of times we get very excited about the new toy, aka the new technology in town, and we want to take it. Like someone comes at a conference and is presenting that, and we are like, yes, this is what I've been lacking all my life. I need this in my project. And then we're going into our project, we are implementing it, and then we are looking at a forum in where we can actually complain about that technology and how much it sucks. Have you been doing this? I see some very sad. I was the one. So I don't think I have to draw a conclusion for this. Consider the context of your project when you're making decisions. Consider the context of your product even in the moment when you are actually being very excited about a new technology, and even when someone that you respect and like very much in a conference or in any other context comes and actually is giving this suggestion to you on what to use or what is the best. Inversion, it's the next mental model that I would like us to touch, that suggests that instead of striving for perfection and brilliance in our code or in our product, it's better to actually look at the common pitfalls and focus on avoiding them. And I'm going to give you an example that it's even more close to, like, I can't fail with this. You know, when you are trying to make your partner happy, well, instead of looking for the 10 ways of making my partner happy and having a great relationship, how about we think about the things that they hate and don't do them? Yeah? For more relationship advice, I'll be outside. Now we continue with software. And an approach that works very well with this inversion mental model is the chaos engineering. Is someone in here? I'm just curious. This is not a question to, just interact with you, but I'm curious if you're using chaos engineering. Anyone? No. Okay. Basically, through chaos engineering, through this concept, we are injecting failures in our system in order to see, like all sorts of failures, in order to see exactly how our system would perform under unexpected situations, such as are the real world, not the ones that we anticipate and we know exactly that we are preparing for. So instead of optimizing for performance and uptime and having everything smoothly, we are asking, okay, but what if things go wrong? What is my approach is if one server just fails to do its job? How do I check, if my load balancer is rerouting traffic effectively, or how my databases are going to handle the sudden load. All sorts of questions that actually we can simulate in order to see how this application would work under unexpected and random events. So this way we ensure that our platform can handle this kind of events and not just the ones that we are preparing for, that we have documented and been discussing about and analyzing, and with which we sometimes introduce also bugs. I really like this, the quote from Charlie Munger again. I'm not a fan, but I really like the guy and how he was thinking. That all I want to know is where exactly I'm going to die so that I never go there. So think about that when you are preparing your systems for success. You might not like me very much, or maybe I might make you a bit sad with what I'm about to say. But we often underestimate simple concepts and overestimate the complex ones. Because many of us build careers on very specialized knowledge because we don't feel valuable if we know what everyone else knows. Even when we are taking decisions without realizing it, we are striving for something more complex, something that gives us meaning and says about us, okay, this is an experienced developer. You can see how he's thinking. He has a complex thinking. It's not like the other developers. Well, this concept, Occam's razor, suggests that as a starting point, always the best solution is the simplest one. Unless you have very specific requirements that tell you, okay, you have to address this problem, so you have to go with more complexity. And you can think of all the situation from maybe when you are working on a dashboard and trying to put everything on it to, the decision between using that input validation library that has a lot of complex things, or just doing some simple input validation in your code. And I'm sure that you have a lot of other examples where you are just overcomplicating work instead of just laying on the simple and start building from that moment on with the requirements at hand. And the last thing that I like to ask you, have you ever been in front of a person and you are telling them this amazing story that you have, or a joke, or something that you've been reading that you are very passionate about, and they are like, yeah, I know that concept. It's just like something that I read the other day. Have you had that experience? Yeah? Do you want to punch them? Yeah? Well, don't be that person, because when we are thinking, okay, I already know this. This is like something that I've been reading about. This is so familiar to me. I don't really have to stretch my thinking into analyzing what's different right now. We are actually limiting ourselves, limiting to new ideas, limiting ourselves to looking at things from another perspective. We are reinforcing our biases, and in the end, we are not really learning something new. So next time you catch yourself thinking, this is just like something that I heard before, just think about it this way. You most probably had a book that you've been reading when you were younger, and then years after, you read it again, and you saw it in a very different light. Same text, a very different perspective, because you are different, your context is different, the information and the experience that you have is different. So also, the way that you're looking at the concepts from that book is different. So we can discuss all day about mental models and frameworks. And as I said, I am recommending that you search for those books from Shane Parrish. But it's not about knowing who knows the most. It's about being honest and being open about the limitation that we have and understanding what we are actually building and what we are working with and how we can apply those mental models in our work. Because yes, we have technologies, we have tools that are amazing. The true impact that we have in our work is coming from the way we are resolving problems, from the way we are looking at the situations that we are dealing with, the challenges, the complex scenarios, and so on. They allow us to build software that not only solves current problems, but it is adaptable for the future, for other situations that might appear, for being extended, for working in expected situations. I'm going to leave you with this quote from Christopher Alexander, because again, he's saying something very nicely. When you build a thing, you cannot merely build that thing in isolation. You must repair the world around it. So we are never just working in isolation on our feature, even if we think this. So please build castles and don't just break stones. Thank you very much, and let's talk.